We've already spent a lot of time talking about how neat carbon is for life and for biology and for chemical reactions, so much so that there's a whole field of organic chemistry devoted to studying the chemistry of molecules that involve carbon. And one of the things that carbon, or two of the things that carbon will often bond with, are itself and with hydrogens. So much so that there's an entire class of molecules that are only made up of carbons and hydrogens. And we call these, it's a very creative name, we call them hydrocarbons. Hydrocarbons. And you will see many, many types of pure hydrocarbons, and you'll see many other types of molecules that at least are partially hydrocarbons or are based on hydrocarbons. So it's a really interesting thing to study. Here's 3 examples of hydrocarbons. These all have the prefix eth in the beginning of them because they have a chain, their longest chain has 2 carbons. And if you want to study how to name hydrocarbons, or actually organic compounds in general, I encourage you to look at the organic chemistry section of Khan Academy, where we go into depth on it. But this is just going to just kind of dip our toe in the water, just so we get a little bit familiar. So these all have the prefix eth, which says our longest chain of carbon. We're going to have 2 carbons over here. But then we see that the ending is different. Over here, we have ethane. And it's an ane because we have a single bond over here. This over here, we have an ene. And that's because we have a double bond. We have at least one double bond in that chain, and the carbon chain is only 2 carbons over here. And it's ethine here because we have a triple bond. The general term for a carbon chain that has no double or triple bonds is an alkane. This is a specific form of an alkane, ethane, that has 2 carbons. If the general form for carbons that have a double bond, that's an alkene. Actually, let me write these general terms down. So I could write alkane. Alkane is the general term for a chain of carbons that has no double or triple bonds, and specifically this is ethane. If I were to speak generally here, I'd say alkene. I would say alkyne right over here. But let's think a little bit about how this bond affects its shape. Well, here I have a single bond, so it essentially forms 2 tetrahedrons with one of the carbons at each of the centers of those tetrahedrons. For example, on the left-hand side here, when I draw this bond when I draw it like this, it means that it's popping out, and when I draw it like this with these lines, that means it's going into the screen. So I could draw a tetrahedron that looks like this. That's the base of it, and then the top of it is at this other carbon, and it has this carbon at the center. And I could also draw another tetrahedron that has this carbon at the center, this carbon at its top, and it would look something like this. So at least for this molecule, you have the shape is kind of, it looks like these 2 tetrahedrons that are kind of overlapping with each other. And because these carbons they have a single bond in between them, these 2 tetrahedrons can rotate. So they could rotate around that single bond. Now, things are a little bit different when you have a double bond. When you have a double bond like this, it actually forces all of these atoms in this molecule to be in the same plane. So this right over here, this ethene, this is planar. This is planar right over here. And this double bond locks it into place. There's not going to be any rotation. When you have a triple bond, not only are you not going to have any rotation, but it's going to make the whole thing a linear molecule. So when we're talking about its shape, we're talking about these molecules, their conformation, how they arrange themselves in 3 dimensions. And if you're curious what these are, ethane is a component of natural gas. Most of natural gas is methane. Methane is just, so if I were to write methane, most of natural gas is methane, which is just one carbon bonded to 4 hydrogens. That's methane right over here. This is the biggest constituent of natural gas, but you're going to find a little bit of ethane in there. Ethene, which is often known as ethylene, this has many industrial uses, but maybe most interestingly, it can be used it's a plant hormone that can be used to ripen fruit. Ethine, or most commonly known as acetylene, this can be used because it burns very, very hot. It can be used to fuel blowtorches. So once again, these seem similar, but they can be used for very, very different things. And I could go all day showing more and more different types of hydrocarbons, but here's just a little bit more variety just so we can think about how they're named and the different forms they take. And these are just three of the different types of molecules you might find in the gasoline that you have in your car. And there's many, many more than just these. And that's because you mix them with oxygen, put them in an engine, and spark them, right? They burn well. They're good fuels to power cars. But just so get familiar with the naming mechanism a little bit more, this is pentane. It's an alkane with 5 carbons. 1, 2, 3, 4, 5 carbons in its longest chain. That's why it's called pentane. Because hydrogens are all of the other bonds that carbons are forming, sometimes you'll see a shorthand where something like a pentane, instead of drawing all the C's and H's, it would be drawn like this. It could be drawn like this, where you assume that there's just a carbon at each of these points over there. So you actually don't have to draw the carbon. And then if something's not bonded to a carbon and there's no other atom that is drawn in that a carbon is bonded to, you assume it's just a bunch of hydrogens. So this is a shorthand for pentane, which is exactly this molecule here. And you see it has this bent shape because carbon is each of the carbons are trying to get to that tetrahedral type of shape. Now this is cyclohexane. Once again, it's an alkane. We have no double bonds there. Hex is the prefix because you have 6 carbons in your longest chain. 1, 2, 3, or you could say your cycle in this case, 5, 6. And the cyclo is because instead of it just being an open chain, it's connected at the end and it forms an actual cycle. This over here looks a little bit more complex. You see the ene at the end, and that's because the longest chain has a double bond right over here. And the but, this is the prefix for 4. This means that our longest chain has 4 carbons, and you see that 1, 2, 3, 4 carbons. But then on this number 2 carbon, not only do you have your double bond there, but you also have a methyl group. 1 carbon. Meth is the prefix for 1. So anyway, the goal of this video is really just to get you a little bit familiar with hydrocarbons and to think about how they'll be useful in chemistry and parts of and you'll see many molecules in biology that have hydrocarbon parts, that have chains of hydrocarbons attached to them, so we can think about the properties associated with them.